This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Ever wondered how light behaves when it switches between different materials? Like, say, going from air to water? It's a bit like magic, but it's actually physics. We're diving into a fascinating simulation today that explores exactly that.
It's all about refraction, the bending of light. It's not just a pretty effect. It's crucial for things like lenses and fiber optics.
So this simulation, 2 media speed, lets you play around with different variables, right? Like the speed of light in each medium?
Exactly. You can adjust the refractive indices, which determine how much the light bends. You can even move the light source around and see what happens.
Sounds like a fun way to learn about a pretty complex topic. Let's get into the details. So tell me more about this 2 media speed simulation. What exactly can we do with it?
It's a really interactive tool. You can change the speed of light in two different media, represented by N1 and N2. You can see how that affects the angle of refraction.
Right. And what about those H1 and H2 values? They seem important.
Those represent the heights of the light source in each medium. Changing them alters the path of the light. There's even a draggable circle to adjust the position of the light source.
So it's not just about watching, it's about experimenting and seeing the cause and effect relationship in real time. That's cool. The simulation was created by Fuqun Huan, Fremont Tang, and Lu Kang, right? Any idea what tools they used?
Yeah, they used EJS, which is a pretty powerful tool for creating interactive simulations. It's open source, so anyone can use and modify it. The simulation is also available in HTML5, making it accessible on various devices.
So it's not like a pretty picture, it's a dynamic tool that anyone can use to learn. I see. The simulation also has stated learning goals, right? What are they trying to teach users?
The goals are to help users understand how light behaves when it passes from one medium to another, and how factors like the speed of light and the angle of incidence affect the path of the light.
And the instructions are pretty straightforward, I assume?
Absolutely. The interface is intuitive. There are checkboxes to toggle the display of velocity vectors and a horizontal line, and sliders to adjust the parameters. It's designed to be user-friendly.
The website also lists other resources for learning more about refraction, right?
Yes, it links to several other simulations and educational websites, including Feet Interactive Simulations, Rusher Fence website, and the Physics Classroom. It's a great starting point for further exploration.
So it's not just a standalone tool, it's part of a larger learning ecosystem. Makes sense. This simulation is hosted on i12study.org, a site with a lot of educational resources, correct?
That's right. It's part of a larger collection of interactive simulations and learning materials covering various subjects, including physics, chemistry, and biology.
So it's a valuable resource for students and educators alike. We saw some HTTP headers at the beginning of the page. Anything interesting there?
The headers show standard web server information like the server type, Apache, the date and time of the request, and the content type, text/HTML. The content encoding, gzip, shows the page is compressed for faster loading. The access control allow origin is important, indicating the resource can be accessed from any origin, which is useful for embedding the simulation in other websites.
So it's all about efficiency and accessibility, right? And there's an iframe embed code, right? What's that for?
That's how you can easily integrate the simulation into your own website or blog. It's a simple way to share this learning resource.
So it's designed for easy sharing and collaboration. We know the creators, but are there any other credits we should mention?
Yes, the simulation is released under a license, although the specific license isn't stated. It also mentions being compiled with EJS 6.0.
So it's open and transparent about its development. The second website we looked at, it seems to be a broader educational platform, right?
Yes, it's a much larger site with a wide range of resources organized by subject and topic. It has a navigation menu, search functionality, and user login.
It's a whole learning portal. The second site also has user authentication, right? What's that about?
It appears to have a login system, requiring a username, password, and a secret key. This suggests some content might be restricted to registered users.
So there's a mix of open and closed content. The second site also has a section for popular tags, right? What does that tell us?
The tags give a sense of the site's content focus, showing popular topics like character and citizenship education, easy JavaScript simulation, biology, and various physics concepts.
It's a way to categorize and find relevant resources. So from a simple simulation about light refraction, we've explored interactive learning tools, open source development, and the structure of educational websites. It's amazing how much you can learn from a single resource.
Absolutely. It highlights the power of interactive learning and the importance of open educational resources.
That was a great discussion.